Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smartyurl.it/Jedi. My advice on how to pass actuarial exams is at smartyurl.it/pass. This video channel is at smartyurl.it/pass actuarial exams. Here you have some information about online seminars, study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smartyurl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smartyurl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. Automobile losses reported to an insurance company are independent and uniformly distributed between 0 and 20,000. The company covers each such loss subject to a deductible of 5,000. Calculate the probability that a total payout of 200 reported losses is between 1,000,000 and 1,200,000. And here's the solution. Because the number of payouts, including payouts of 0 when the loss is below the deductible, is large, and losses are independent and identically distributed, we can apply the central limit theorem and assume the total payout, that's right, S for it, is normal. So it follows a normal distribution. For a given loss, there is no payout with probability 0.25, or a payout of 0, and otherwise with probability 0.75, the payout is uniformly distributed between 0 and 15,000, because the loss itself is uniformly distributed between 0 and 20,000, but we subtract the 5,000 deductible, and so the payout, when it happens, is between 0 and 15,000 and uniformly distributed. Therefore, if you write x for the payout, E of x is equal to 0.25 times 0 plus 0.75 times the expected value of uniform distribution between 0 and 15,000, which is 7,500, and that's equal to 5,625. And the second moment, E of x squared, is equal to a weighted average of the second moments of that degenerate distribution with value of 0, happening with probability 0.25. So 0.25 times 0 squared, which is the second moment of something that is equal to 0 all the time, plus 0.75 times the second moment of that uniform distribution between 0 and 15,000, which is a square of the first moment, so 7,500 squared, plus the variance, which is the length of the interval, 15,000 squared, divided by 12. And we calculate this to be 56,250,000. Therefore, the variance of a single claim payout is E of x squared minus the square of the mean, and that's equal to E of x squared that we have here minus the square of 5625, and we calculate this to be 24,609,375. Now we apply the central limit theorem, and we will use the notation z for the standard normal random variable and phi for the CDF, cumulative distribution function of z. And the question is, what is the probability that S, the total loss, for 200 such policies, is actually a total payout, not total loss, total payout, is between 1,000,000 and 1,200,000. What's the probability that 1,000,000 minus 200 times the mean, which is the mean of the sum of 200 policies, over the square root of 200 times the variance for individual policy that we calculated. And of course, since they're independent, the variances are added, so the total variance is 200 times individual variance, and the square root of that is the standard deviation, is less than S minus that mean 200 times 5625 over square root of 200 times 24609,375, and less than, now we subtract the same mean and divide by standard deviation, but for 1,200,000. That's actually approximately equal to the probability that negative 1.7817 is less than z, because after we subtract the mean of s and divide by standard deviation, because s is a sum of 200 independent identically distributed random variables, by the central limit theorem, s is approximately normal, so when we standardize it by subtracting the mean and dividing by standard deviation, it becomes standard normal approximately. So therefore we have the probability that the standard normal z is greater than negative 1.7817 and simultaneously less than 1.0690. That's equal to the difference of values of the cumulative distribution function of a standard normal, phi at 1.0690 minus phi at negative 1.7817. But phi of negative 1.7817 is 1 minus phi of 1.7817, and we're subtracting that phi of negative 1.7817, so this becomes phi of 1.0690 plus phi of 1.7818 minus 1. We look up these values in the table. That's 0.8577 plus 0.9625 minus 1, and the result is 0.8202, which is answer D. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.